The baseball diamond problem. It's number 11 on your homework. It says, suppose a certain baseball diamond is a square 70 feet on a side. The pitching rubber is located 47.5 feet from home plate on a line joining home plate and second base. A, how far is it from the pitching rubber to first base? So what I've done here is I've drawn my baseball diamond. I even tried to draw my little bases, right? Okay, so, and I labeled everything. I labeled the 47.5 from home plate to the pitching mound, and I labeled 70 feet from home plate to first base. Now, what you need to know here that you probably didn't is that each of these angles is 90 degrees. So when I draw this line from home plate to second base or to the pitching mound, this angle here is 45 degrees. They expect you to know that, but most of my students did not know that last year, but that helps you. So now what you have is you have a side, an angle, and a side. So we can use the law of cosines to find this distance right here. And I called it A. So I have A squared equals B squared plus C squared minus 2BC cosine of A. You plug it all in, figure it out. A squared is 2454. So A, when I take the square root, is 49.54. Now part B, this one they might have tricked you on. It says, how far is the pitching rubber to second base? So they want to know from here to here, this distance right here. Well, what I did is I've listed here, there's several ways you can do it. You could just use plain right triangle trig and say the cosine of 45 equals adjacent over the hypotenuse. Or what I did here is I just used plain old Pythagorean theorem. So I drew the triangle here. This is home, first, and second. See, it's this triangle here. I tried to outline it in light blue. But this is 70, this is 70, and this is 90 degrees. So I did A squared plus B squared equals C squared, right? And I found that the whole distance from home to second base is 98.99 feet. See, 70 squared plus 70 squared equals C squared. Now I needed to find this distance, so I just did my 98.99 minus the distance from home to the pitching mound. So I subtracted the 47.5 and I got 51.49. Just plain right triangle stuff right there. See, now they want to know what the angle the pitcher has to turn if he's facing home to first base. So I highlighted it in purple here. I hope you can see that. We go back to the law of cosines here. If you're finding this, I labeled this as my B squared. So I set B squared equals A squared plus C squared minus 2AC cosine of B. But now we know A from the first part. So you can see I plugged it all back in and I got, don't be surprised when your cosine of B is a very small negative number. Plug it in. The cosine inverse of this very small negative number is 92.3 degrees. And it makes sense. It's going to be a little bit greater than 90 degrees. Okay, more application problems to come, guys.